Welcome back to Math on the Fritz with Mr. Fitz. And today we're going to be looking at solving equations that have radicals in them. And you can see that they get progressively more difficult as you move across here. We're going to start with the first one over on this side, which has a radical on one side and just a number on the other side. So this is no problem. We can't really get this out from underneath the radical in any way. The only way we've been trained to pull things out of radicals is if you have pairs, and clearly I don't have a pair of anything in here. Matter of fact, I have more than one term in here, which is a nightmare. So instead of trying to deal with the radical, we're just going to square both sides. So if I square this side, and I square this side, then I'm going to be able to get rid of that radical. Now, in case you're wondering who thinks of this stuff, well, if these two values are actually equal, then squaring them shouldn't matter. 5 squared is 25. If 5 equals 5, then if you squared both sides, you'd have 25 equals 25. So you haven't changed the property of equality by squaring both sides. But what you have done is made this radical disappear. Because now when I square both sides, I have a pair of these and it can pop out. So when I square both sides, all I did was wiped out that radical on the left side. And I just copied the things that were inside. But on the right side, since it was just a number, I know how to do 8 squared. 8 squared is 8 times 8, which is 64. So in a very fast way, I was able to get this r free, get this 3 free, and I can get the 3 out of the way to get my answer. So I end up with an answer of 63, and I'm happy. One step, and it's done. Now on this one, I have a radical on both sides, but that's okay because there's no free number floating around. Everything on this side is under the radical, everything on this side is under the radical, so I can do the same trick I did before. I square this side, I square this side, and the radical's gone. Yes! Victory lap. 5 plus r, 3r minus 7. That comes out just like it is. Nothing was changing because I squared both sides, but they were under the radical. The radical and the exponent undo each other. They're inverses. It's gone, and I'm just left with whatever was inside. Now, that's an equation that I feel very confident. You have great abilities to solve. Subtract the r, add the 7, and I get 12 equals 2r, quickly solvable to r equals 6. Again, we were able to get to a pretty nice, pretty quick solution. But on this third one, it doesn't go as quick. So when I look at this third one, I'm thinking, well, I've got to square both sides because I can't do anything about this radical. The issue is I have a variable over here. So when I square that side and square this side, I actually get x squared over here. And over here I get 7x minus 10. Some of you may recognize when I'm putting these together as polynomials, if I bring them all to the same side of the equation, subtract 7x, add 10, I would have a trinomial. And when I have that trinomial, I would like to factor it, because factoring I can do without a calculator. Sometimes when you're solving polynomials, you could either factor it, you could use completing the square, you could use the quadratic formula. These are all good ways to get an answer, but factoring is easiest to do without a calculator, without technology. So I look at this and say, well, if I'm going to factor this, then I need to know what the factors of 10 are, 1 times 10 or 2 times 5. I'm going to go with 2 times 5 because I know that 2 times 5 will give me 10. I know that 2 plus 5 will give me 7. And because this is negative, this might be bringing you back to a lot of prior math, I'm going to be saying this is a product of 2 binomials. In order to get x squared, I need x times x. In order to get 10, I need 2 times 5. But notice it was a negative 7 in the middle. That means both of these had to be negatives. Remember, if I were distributing in my mind, I'd have x squared minus 5x minus 2x plus 10. that's going to give me exactly what I wanted. Now, the reason I factored this is because I'm trying to write it as a multiplication. Two numbers multiplying to give me an answer of 0 means that one of these two factors had to be 0 in order to get that product. So I could now derive that there's two possible answers to this problem. If x were 2, I'd have 2 minus 2, which is 0. So I know that x could be 2. Or I could have made x equal to 5, because 5 minus 5 is 0, and I would get 0 as a product. So I know that x could be 5 as well. So these ones are a bit longer to get through. It's no different when you start the problem. You still square both sides, just like I did on this problem, squaring both sides, just like I did on this problem, squaring both sides. But because I had an x squared left over, I had to try to factor a trinomial. Again, if you get a problem that you can't do that with, you would have to use either completing the square or something of the such. But most of the ones that you're going to see for the purposes of our work is going to be factorable, and you'll end up with a couple answers. So as you go through these, especially when you get to the bottom of the assignment, if it's a little beyond where you're at, feel free to send me a message somehow and say, hey, I'm not seeing how this one works out. It's probably something like this where you end up having to factor. So I hope this helps you understand what the process is, and good luck solving these equations.